Hello viewers, in our today's lecture we'll solve some problems on differentiation. Viewers, I have already discussed in detail regarding continuity and differentiation. Now in today's lecture we'll solve some tricky questions, some important questions, and uh, some questions which require concepts. So let us start with the first question. If y is equal to square root of sine x plus y, then we have to find the derivative dy over dx. Clear? So let us start. So here we have now let us square both sides. So squaring both sides, we get y square is equal to sine x plus y. Now take this y to the left hand side. Viewers, now differentiate both sides. So if we differentiate both sides with respect to x, okay, so we have 2y dy over dx, because the derivative of y square, always remember, with respect to y is 2y dy over dx, but the derivative of y square with respect to y is simply y. Clear? So here we have 2y dy over dx, and then y is the derivative of y is dy over dx, and the derivative of sine x is cos x. Clear? So taking dy over dx common, we have 2y minus 1 is equal to cos x. So dy over dx is equal to cos x over 2y minus 1. So this is the required value of the derivative of y with respect to x. Clear? Now the second question is, if f of x is log of log x, find f prime of e. Clear? So where's f prime of e means we have to find the derivative. If it is y, say, then we have to find dy over dx at x equal to e. Clear? So let us differentiate this function. So we have dy over dx, that is f prime of x, is equal to, we know that the derivative of log x function, the derivative of log ex is equal to 1 over x. So here if we apply, then we have 1 over log e of x, because this is log of log x, and we have log of, say, this whole quantity is x. So we have 1 over log x. Then by chain rule we differentiate log x. So we have 1 over x. So this is the value of the derivative. Now we have to find f prime of e. So f prime of e is equal to log of e, and then we have 1 over e. Now we know that log of e is equal to 1. Here the base is e. So we have 1 over 1 multiplied 1 over e, that is equal to 1 over e. Clear? Suppose if we have to find the value of e square, then we'll substitute here log of e, this is e square, then we have 1 over e square, then we apply the formula, say log m raised to n is n log m here. So we have 2, we'll take 2 to this position here, 2 times of log e, then we have 1 over e square, log of e is 1, so we have 1 over 2 multiplied e square, and finally we have half 1 over 2 e square. Clear? Okay, let us take the third question. So here we have the problem y equal to x cube plus 10x, and we have to find the second derivative. This is called the second derivative. Then we'll differentiate it. This is dy over dx. The derivative of x cube is 3x square, and the derivative of 10x is secant square x. Clear? Now again we have to differentiate both sides because this is d2y over dx2. So we have d2y over dx2 is 3 times the derivative of x square is 2x plus 2, the derivative of secant square x is 2 secant x, then the derivative of sec x by chain rule. So this is sec x 10x. Clear? So here we have 6x plus 2 secant square x 10x. Clear? Now if we want to express it in terms of x and secant square secant x and y, then from here we can write 10x is equal to say y minus x cube. Clear? So here we can write 6x plus 2 times of secant square x times y minus x cube. So this can also be written here, and this is the required value of the second derivative of y with respect to x. Clear? So viewers, here we have the next question. If 2x plus 3y equal to sine x, we have to find the second derivative of y with respect to x. So here we can differentiate both sides. So what we'll get 2 times of 1 because we are differentiating both sides with respect to x. We can write here, we can also write it like this. We can have d over dx of 2x plus 3y equal to d by dx of sine x. Clear? So the derivative of x is 1, so this is 2 times 1 plus 3 times of dy over dx, and we have the derivative of sine as cos x. Clear? So we have 2 plus 3 dy over dx equal to cos x. Now again differentiate both sides with respect to x. So we'll get the derivative of 2 is 0, and this is 3 times the derivative of y because we'll differentiate this one, and the derivative of cos x is minus sin x. So here we have d square y over dx square is equal to minus sin x divided by 3. Clear? So this is the required derivative. Clear? So viewers, let us take this problem. If y is equal to tan inverse of x divided a, we have to find the derivative dy over dx. Now we know the derivative of tan inverse x is given by 1 over 1 plus x square. Clear? So here what we will do, we will find the derivative as 1 over the derivative of tan inverse x is 1 over 1 plus x square. So this term will become 1 over x by a whole square, then we'll multiply the derivative of x over a. So the derivative of x over a by chain rule. Clear? So whereas here we have 1 plus x square over a square multiplied, the derivative of x is 1, so we are left with 1 over a. Then we take we simplify this expression, so we have a square over a square plus x square multiplied 1 over a, and here we cancel this a, and we are left with a over a square plus x square. So this is the required value of dy over dx. Clear? So viewers, now we have the problem. If fx is equal to cos inverse of sin x, then what is f prime of x? That is where we have to find the derivative of f. So the derivative of f is the derivative of cos inverse of sin x. Clear? So here we have to apply the formula for the derivative of cos inverse of x, and this is given by minus 1 over 1 over square root of 1 minus x square. So here if we apply it, then we will have square root of 1 minus, here we have sin x, so this is sin square of x, and then by chain rule we'll differentiate this sin x, so we'll have here cos x. Clear? Sin x, the derivative of sin x is cos x, so this is minus, and square root of 1 minus sin square x is square root of cos square x, because 1 minus sin square theta is equal to cos square theta. So here we have cos x, so this is minus, we take this cos x from the square root sign, so we have cos x here, and this is multiplied by cos x, and then cos x and cos x get cancelled, and here we have minus 1 as the answer. So f prime of x is equal to minus 1. So viewers, this is the first derivative, and here we note an important point, and the point is, if we want to find the second derivative, f double prime of x, then it is obviously 0, and all the higher order derivatives are 0. All the higher order derivatives are 0. Derivatives are 0. This is an important point here, because the derivative of fx, the first derivative, is a constant. Here we have minus 1, so f double prime of x is 0, and other higher order derivatives are also 0. Clear? Now viewers, we have one important problem here. If fx is e raised to x multiplied gx, and g of 0 is 2 and g prime of 0 is 1, then we have to find f prime of 0. Clear? So here what we will do, we'll differentiate this function, that is this function here. Clear? So f prime of x is equal to, since this is the product of two functions, and we have already discussed this formula for the derivative of two functions, product of two functions. So we have u times dv over dx plus v and du over dx. Clear? So this is the derivative of product of two functions. So here we will apply. So we have e raised to x, then we have the derivative of g, which is denoted by g prime of x, then we have gx, and then the derivative of e raised to x is e raised to x. Now substitute here x equal to 0. So f prime of 0 is equal to e raised to 0 g prime of 0 plus g of 0 e raised to 0. So e raised to 0 is 1, g prime of 0 is 1, and g of 0 is 2, and e raised to 0 is 1. Clear? So we have 1 plus 2, that is equal to 3. Clear? Now viewers, we have a very interesting problem here. If y is tan inverse of x plus cot inverse of x plus sec inverse of x plus cosec inverse of x, we have to find the derivative of y with respect to x. So viewers, at first glance this problem, it may seems to be very difficult at first glance. Clear? But this problem is very easy, and we have to take a close look to the problem, and here we have to apply two identities from inverse trigonometric functions, and once we recall those identities, the problem becomes very easy. Let us see. So we know that tan inverse of x plus cot inverse of x is equal to pi by 2. Clear? Similarly, we know that sec inverse of x plus cosec inverse of x is equal to pi by 2. Clear? So this becomes pi by 2 and this becomes pi by 2. So whereas we have pi by 2 plus pi by 2 and it becomes pi. Clear? So y equal to a constant. Pi is a constant, and if we find dy over dx, then we get 0. Why? Because the derivative of a constant is 0. Clear? Now we have this problem here. We have y equal to log, and here the base is 7, so log 7 log x, then we have to find dy over dx. Now here I want to tell you the formula for changing the base, and the formula is log. If we have, say, here we have the base a and here we have b, then if we want to change this base a to e, then we have log e of b divided by log e of a. Clear? So this is the formula here. Now let us convert this expression log of 7 of log of x. So this can be written as if we change it to the base e, so we have log e of log x here, and then we have log e of say 7 here. Clear? So by this formula we have reduced this expression to this. Clear? Now let us find the derivative. So dy over dx, now this becomes the constant, so we take it here log e7, and then we have to differentiate only this term log e of log x. Here e is understood, so we have only log x. Clear? So we have log e7, then the derivative of log x is 1 over x, which is here log x, and then we differentiate log x, so we have 1 over x. Clear? So here's the final derivative is given by 1 over x log x, and then we have log e of 7. So this is the required derivative. Clear? Now viewers, suppose in this problem if you want to differentiate the function, say here we have only log x. Suppose here we have log 7x. Okay? And we have to find this derivative dy over dx. Then again what we will do, we will apply the same formula, which is log a of b, and we'll write this function log 7x can be written as log of ex over log e7. Clear? So now we differentiate both sides, so dy over dx is equal to this log e of 7 is a constant, so we have log 1 over log e7 multiplied the derivative of log ex, which is simply 1 over x. So our final answer is 1 over x log e7. Clear? Now let us take this problem here. Y equal to square root of a square plus x square, and we have to find dy over dx. So here's what we will do. We'll differentiate both sides. So we have d over dx of square root of a square plus x square. Now we differentiate it by using chain rule and by making use of this formula, that is x raised to n, this is nx n minus 1. So we have 1 over 2 square root of a square plus x square. This is the derivative of square root, because the derivative of square root of x is 1 over 2 square root of x. And then we'll differentiate this function a square plus x square, which is 0 plus 2x, because a is constant and the derivative of x square is 2. So this 2 and this 2 get cancelled, and we are left with x over square x divided by a square root of a square plus x square. Clear? So this is the required derivative. Clear? Now viewers, let us take this problem. If y is equal to cot inverse 1 over x, then find dy over dx. Now we know that the derivative of cot inverse of x is minus 1 over 1 plus x square. Clear? So here we have dy over dx is minus 1 over 1 plus 1 over x whole square, because we'll apply the chain rule here now, and the derivative of 1 over x, always remember viewers, the derivative of 1 over x is equal to the derivative of x inverse 1. Clear? X inverse, x raised to minus 1, so it is minus 1 over x square. Clear? So here we have minus 1 over x square. So minus minus plus, and here we have 1 over x square multiplied 1 over x square. So we simplify this expression, we have x square and x square plus 1 multiplied x square. X square times 1 x square, and then we take x square to the numerator. So x square get cancelled, and we have 1 plus x square. So this is the derivative of y with respect to x. Now suppose if we want to find the second derivative, then what we will do? So if we want to find d square y over dx square, then it means we have to differentiate this function, and we write it like this, 1 over 1 plus x square. We can write it d over dx 1 plus x square raised to minus 1, and then we have minus 1 over 1 plus x square whole square, and then we differentiate 1 plus x square, which is equal to 2x. Clear? So here we have minus 2x over 1 plus x square whole square. So this is the second derivative of this function. The first derivative is 1 over 1 plus x square, and the second derivative is minus 2x over 1 plus x square whole square. Clear? So viewers, let us take this problem, and here we have to find the derivative of y with respect to x, and the function, the expression is x cube plus y cube is equal to 3a xy. So let us differentiate both sides. So differentiating both sides with respect to x, so we get 3x square, the derivative of x cube is 3x square, the derivative of y cube is 3y square, and then we have here dy over dx equal to, this is 3a, and here we have the product of two functions, so we have x, this is dy over dx plus y multiplied 1, because first function derivative of second, then second, and multiplied by the derivative of x, which is 1. So here we have we cancel out 3 here, so we have x square plus y square, this is dy over dx equal to a times of x dy over dx plus y. Clear? Now for the sake of simplicity, I am writing dy over dx as y prime. Clear? So this is the y prime. So I will write y square here, y prime ax y prime plus ay. Clear? So we rearrange this equation and we have ay minus x square. Clear? So we take y prime common, so we have y square minus ax is equal to ay minus x square. Clear? So y prime is ay minus x square divided by y square minus ax. Clear? So this is the value of dy over dx. Clear? So in today's lecture we have solved some problems on differentiation, and I hope this lecture is very fruitful for you, and in our next lecture we'll see some more problems on differentiation, and I have uploaded many videos on different concepts of mathematics, so keep watching those videos. Till then, goodbye.